Okay, starting with our investigating percentage change. Springfield had 50 murders last year as the capital city. Both cities have the same population, so there's no difference in crime between these cities, right? Maybe, maybe not. Let's go back and look at the number of murders of those towns in previous years so we can determine the change over time. The amount of change. So let me be clear. I got to go back and find the original. So let's say Springfield had 50 murders over last year. So I'm going to underline Springfield and 50 murders over last year, okay? And then Capital City had the same amount. So Capital City had the same amount. So I'm going to put a 50 on top of Springfield and 50 on top of Capital City. Now there's information here too that says 2 years ago, Capital City had 45 murders and Springfield had 27. So Capital City had 45 and Springfield had 27. This was 2 years ago, and in the original problem, we're talking about 1 year ago. So the new part has to be this 50 years ago, and the original had to be 2 years ago. So for Capital City, the new is 50 years ago, because that's only 1 year ago, and the original was the 45. So 50 minus 45 is going to give me 5 is my amount of change. Now, I want to divide the amount of change by original. This is how I can get something they call percent change. So I put my amount of change, which is 5, and then my original over here is 45. I put that on the bottom. I do that division. You do that division really quickly. So we get, on the calculator, 5 divided by 45, and we get 0.11, and the 1 extends on and on. And it says convert the decimal to a percentage, round to the nearest whole. So if I got 0.11, let's say 1, and I'm converting it to a percentage, that means I move my decimal over twice, multiplying by 100, I'm going to be left with 11.1, and if we're going to the nearest whole, so that means we're going to have 11%. So in my mind, I'm thinking, okay, they started with 45, they went up to 50, so they only went up 11%. All right, let's look at Springfield now. Now Springfield, it says here, the amount of change. Well, let's go back and see what's up with Springfield. Now, if I go back here, Springfield 2 years ago, and I'm on this 2 years ago, was at 27. So their original was 27. And their new amount, since they were the same, is 50. So for Springfield, the original is 27 and the new amount is 50. So when I subtract here, 50 minus 27, I get equal to 23. 23 is my change. So it says the amount of change over the original I want to divide. Amount of change is 23 because it went up by 23 from there. And the original was 27. I just have that from right here that I know. And then I do that division. So I have 23 divided by 27 is equal to, so the value that I get is 0.85185. Now I'm not going to need all of these, but I'm just going to put a few of them. Convert the decimal to percent. So I get 0.851. Let's stop it right there. And 0.8518, let's go. So then from here, I want to convert. I'm moving the decimal over 2 times to get to percent. You multiply by 100. So I'm left with 85.18. And if I'm rounding to the nearest whole number, this is going to give me 85%. That's quite interesting. I mean, even though the crime rates are the same this year, but there's definitely a big difference in the changes so far. Well, let's write that out. Okay, start with Capital City. Capital City had a what? 11% increase in 2 years. Whereas Springfield had an 85% increase. So even though they had the same amount of crime in that second year, in that year, like 1 year ago, the difference is so large, 11% and 85%. So why do we find percent change? Well, it's simple. We can use percent change to understand how a quantity, and there's many different quantities, not just crime rates, changes over time.